Now we are ready to consider an example from this section. So here, so basically we want to calculate the line integral of a vector valued function, and it is defined using this right hand side. So basically you have an integral that goes from a to b of this integrand. Now in this integrand, your vector field f should be evaluated on this curve c of t, and then calculate c prime of t. Finally you should take this dot product, and after that you should do this integral. Let's consider this example. So here our curve c of t equals to sine of t comma cosine t comma t, and t goes from 0 to 2 pi. Our vector valued function f equals to 2x comma 2y comma 4c. So the first component of the vector field is f1, which is 2x. The second component equals to 2y, and third component is equals to 4c, and we want to calculate this line integral. Now using this definition, line integral of f vector field f dot ds equals to line integral goes from a to b of vector field f on the curve ct dot c prime t dt. Now as you can see, when we take the dot product between two vectors, you will get a scalar function. Okay, so now lower limit of t should be 0, upper limit of t is 2 pi. Now let's evaluate our function f at c of t, which is given by sine t comma cosine t comma t dot, okay, what is c prime t? Okay, let's write c prime t here, dt. Now my vector field f equals to 2x comma 2y comma 4c. So this becomes, x coordinate is sine t, so we have 2 sine of t comma 2 y coordinate is cosine t, and comma 4 times c coordinate is t. This is x, this is y, this is c dot, okay, c prime of t, which equals to derivative of c of t, cosine t comma minus sine t comma 1 dt, and this equals to integral from 0 to 2 pi, so this should be 2 pi. Now let's calculate this dot product. You will get 2 sine t cosine t. So you should multiply the corresponding components and add them together. Then you will get minus 2 sine t cosine t plus 40 times 1 is 40. This is your new integrand. Now we can cancel this term with this one. Now our integrand simplified to 40 dt. We can take 4 out from the integral. Integral of t is squared over 2. Lower limit is 0, upper limit is 2 pi. Okay. And if you apply the upper limit, you will get 2 pi squared over 2 minus the lower limit is 0. So this equals to 4 times 4 pi squared over 2, which equals to 8 pi squared. This is the value of the line integral of this vector field f.